Well, my name is Kevin Liu, and this is my Discovery Project showcase. This semester, I built a modular direct conversion radio receiver. It's modular because there are four modules: an oscillator, bandpass filter, a mixer, and an audio amplifier. And it's a direct conversion receiver because it directly converts from radio frequencies down to audio frequencies so they can be listened to. I wanted to go with this project because I wanted to gain skills in soldering, using lab measurement equipment such as an oscilloscope, signal generator, multimeter, LCR meter, and a power supply. Wanted to gain some experience with learning how to read analog circuits and debug them physically, and to have experience with working with transistors, diodes, and circuit networks such as amplifiers and learn a bit about RF fundamentals, radio frequency engineering. The first hurdle in this project was sourcing the parts. This wasn't a kit project. I had to actually go through and order parts from vendors such as Mauser and Jameco. Um, I then went on to building the circuit. The hard part with this was learning how to exactly translate from an LT-SPICE schematic into an actual physical circuit. This was my first experience, well, beyond breadboarding circuits, but with actually translating a lot of working parts onto a physical circuit. And that meant learning how to do board layout, especially with the limited space on my copper clad board. I went about building each module, the oscillator, using my equipment to confirm my readings, um, take measurements on the oscilloscope to confirm that I'm getting the correct behavior that I need, which is a 7 megahertz sine wave for the oscillator. Um, I have documented my progress here on my website, built the bandpass filter, um, breadboarded it first, tested it on the network analyzer to confirm that, it filters signals and has a bandpass of the range that I want and attenuation for frequencies outside of that range. Went about soldering the components onto the board and testing it further on the oscilloscope and vector network analyzer. Built the next stage of the receiver, which is a mixer. This was the hardest stage. I realized in the process that I had bought the wrong toroid size, which was not giving it the correct inductance that I wanted. So I had to order from Amazon the proper toroid size, winding the toroids with magnet wire and soldering the leads into the proper nodes that they need to go to. That was the other hurdle. I was getting the leads mixed up. There's a diode ring mixer. There's a diode ring, and some leads have to go to ground, others to parts of the ring, and other parts to different nodes. So a lot of moving parts. Confirmed the behavior on the oscilloscope and I'm confirming that mixing is happening and producing a 1 kilohertz tone or signal, which is the audio frequency that I want. Then built the audio amplifier and demonstrating my that the amplifier works. And then I put all of the four modules together and I built a fully functional receiver. And I have uploaded some videos of me testing the radio to show that it does work. If this YouTube short link is better at demonstrating the sound quality. It's not optimized. I haven't confirmed that it can tune up and down the entire 40 meter band, which is 7 to 7.3 megahertz, but it can at least produce receive signals, which I'm happy with. Overall, this project was really fun. I learned a lot. There's a lot of hands-on experience required with it soldering using the lab equipment and learning how to actually translate a schematic onto a physical board. And it's got me thinking about changing my thread over to the electromagnetics sensing thread. Maybe would be open to taking some classes in RF engineering and antenna engineering. But yeah, thank you so much for listening, and I hope you enjoyed and can take a time to go through my website and learn more about it. Thank you.